In this session, we will continue the legacy of our organic named reaction that we have completed 11th name reactions on our YouTube channel. Okay, you can go on channel and one playlist I have made from organic name reaction. You can access all the name reaction. Okay, so in this session we are gonna talking about the 12th organic name reaction, that is a benzoin condensation. Okay, this is a benzoin condensation reaction. Okay, so in this session we are gonna discuss their mechanism, how the reaction happen, what is the reason behind this mechanism, how why this nucleophile attack this position, why not this position, why the base take proton from this position, why not this position. Okay, these are all things I will tell you in few minutes. Okay, and now you are seeing the reaction on this screen. This is a general scheme of this reaction. Okay, so this is a substrate, right? This is a substrate and this is a catalytic cyanide ion, right? This is a reagent and here cyanide is acting as a catalyst. Okay, we will talk about all these things in detail in mechanism, right? And you got a product, this. So now we are gonna see what is happening in this reaction. Okay, so now let's start their full detailed mechanism, how the reaction is happening. Okay, so let me clear this all. So I have a reaction Ar double bond O, here H, and here we have taken Cn minus. Okay, so we know that Cn minus is a nucleophile, right? Okay, but in this reaction we have taken NaCN as a catalyst. Okay, and the main work of the catalyst is may participate in the reaction, may participate in the reaction, but in the last after the product formation, the catalyst will be regenerated. The catalyst will be regenerated. Okay, so this is the very important point, because you must have to know that what's the role of a catalyst, how it acts. So catalyst can be participate or maybe participate in the reaction, but after the last product, in the final step, the catalyst has to be regenerated. Okay, right? Okay, so what happened? We are saying this Cn minus is a nucleophile. You already know that. Okay, and you are also seeing here this is a carbonyl functional group, and we know that here is a C double bond O, and this center is an electrophilic center. Why it's electrophilic center? Because here is this O, because due to difference in the electronegativity, of carbon and oxygen. Okay, so because oxygen is a more electronegative and the carbon is a less electronegative, and that's why there will be a formation of a polarized charge between this carbonyl position. We can say here is a delta minus charge and here is a delta positive charge, and that's why this center, this carbon, is a electrophilic center. It means the nucleophile will attack on this electrophilic center. And how it attack, I will show you in few minutes. Okay, so let me clear all this. So here we have Ar, and here here we have Ar, and here we have double bond O, and here we have H, and here is a Cn minus acting as a nucleophile. So it will attack on this electrophilic center. This is the electrophilic center, right? This carbon, this position, this carbon is electrophilic center. Electrophilic center, and that's why, because the Cn minus is a nucleophile, Cn minus is nucleophile, so that this Cn minus will attack on this carbonyl center, and then after the attack happen, this double bond is shift on this oxygen as a negative charge. So you will get something like this, because the reaction is a reversible reaction. So we have to show the double arrow, and here we will get something like this. Here is the O minus, here is the Cn, and here is the H. Cn, let me simplify this, C triple bond N, right? And this is hydrogen. Now you see in this step, here is a O minus, right? Here is a O minus, and you know that the O minus is acting as a base here. Why it's acting as a base here? Because this proton is a more acidic proton. This proton is a more acidic proton. Why it's a more acidic proton? Because after the removal of this proton, so then it will get a negative charge here, and because here is a cyanide is attached, and that's why this negative charge is delocalized with this cyanide ion. It means this negative charge is more stabilized due to minus M of C triple bond N. Okay, if anyone have asked you why this proton is more acidic, so you have to say that because after this proton removal, here it will become a negative charge, and that negative charge will be stabilized due to minus M effect of a C triple bond N. Okay, right? And that's why this proton is more acidic. And so that, because in this compound here is a O minus, here is a O minus is also present, and we know that here is a negative charge, here is the electron density, and that means it will act as a base and it will take proton this hydrogen. Okay, so how it takes, let me show you, right? So here what happened, here is the Ar, and here is the O minus, and here we have Cn, and here we have H. So this O minus will take this proton, because this proton is a more acidic proton. And after that what happened, let me show you on the next screen. Okay, so if you want, you can take a screenshot of this whole screen. Now we move ahead. Okay, so the base O minus is acting as a base here, and it will take proton from this carbon, because this proton is more acidic due to after the removal of this proton, here it will be negative charge generation, and this negative charge will be delocalized to this C triple bond N by minus M effect. Okay, right? Okay, fine. So what happened in the next step, I will show you. So wait. Okay, so here we got something like this. Here is a O minus, and here we have C triple bond N, and here is a hydrogen, and due to hydrogen is a more acidic proton, and that's why this O minus will take proton from this carbon proton, and then you get something like this, OH, and here is a C triple bond N, and here is a negative charge. And now this what happened, Now this negative charge is acting as a nucleophile. This negative charge is acting as a nucleophile, right? Because we have an electron density. Okay, so this carbon nucleophile, it becomes as a carbon nucleophile. So after the proton removal, the negative charge comes on the carbon, and that carbon will acting as a nucleophile. So in the solution also we have a same molecule present. One second, wait. In the solution we have a different same molecules are, so many molecules are present, and that's why here we have the starting material, and this nucleophile will attack on this carbonyl position, because this position is a electrophilic due to here is a delta minus charge and here is a delta positive charge due to electronegativity difference of this carbon and oxygen, right? And that's why because this is an electrophilic center, and that's why this negative charge, this nucleophile will attack on this carbonyl center, and you get something like this. Here is the Ar, here is a C triple bond N, here is the OH, and it will attack. So after the attack, this double bond will shift on the oxygen as a negative charge. So you will get here negative charge, and here is also a Ar, and here is a H, right? That's all. Yeah, that's all. Okay, fine. So yeah, that is fine. So what happened next? Because here is a O minus, and in this compound we have a acidic proton is also present. This hydrogen is a acidic. This hydrogen is an acidic proton, and that's why this O minus will take this proton. And after taking the proton, it will form something like this: O minus, C triple bond N, and here you will get OH, and here you will get Ar, and here you will get hydrogen, right? And then because we know that we have taken as a catalyst, we have taken the cyanide as a catalyst, so the catalyst has to be regenerated. And how it will be regenerated? This O minus charge will come back. This O minus charge will be gonna come back, and after this comeback, the Cn minus will be leave as the original catalyst that we have taken in the starting material. Okay, so here you will get something like this. Let me erase. Okay, let me erase. Oh, wait. Let me erase this. Okay, fine. So what happened next? So we get something this like product. OH, Ar, and here hydrogen. This is our final product of this reaction, of this benzoin condensation. Okay, final product of this name reaction, benzoin condensation. This is the final product of this reaction. Okay, so this is a very easy, right? Just you have to identify. You must be knowledge of electrophile, nucleophile, acid, base, mesomeric effect. These are all things. Okay. So now I am taking a very good example, very best example, very conceptual example that you will have to think. Okay, you will have to apply some more concepts. That is because it's a multi-conceptual question. Okay, so let me take a second question. That's a very important question. Okay, so now let's start. This is very a star question, very high rated. Suppose you have a reaction something like this. Here is a OAT, here is a OMe, and you have here aldehyde attached, and then you have something like this, benzene, chlorine, and here we have aldehyde, and we are doing this reaction with NaCN ETOH. NaCN ETOH is the solvent, right? 81%, right? So what will be the product will be formed? What is the product will be formed? So you have to tell me, right? So let's start. Okay, so first thing, what you think? Okay, I will tell what you are all thinking. So what is the possibilities of the reaction? Okay, so the possibilities of the reaction is, you either can think that this Cn minus will attack on this, and then after this, then after this. So it's like a nucleophilic aromatic substitution, right? You can also think this nucleophilic aromatic substitution, right? So if you do this step, so what is the work of this step? So what is the need of this substrate, right? What's the need of this substrate? Nothing. Okay, right? So what we do because this step is wrong. We can't do this. If we have not this, only taken this, then we can do this. Okay, then we can do this. Then the reaction will go from the nucleophilic aromatic substitution, but we have taken here this substrate also, and you are saying that I am gonna attack on this carbon, and then the nucleophilic aromatic substitution will be happen. But okay, let's suppose if it will be happen, but what about this? What are you gonna do this? What is the use of this? Why have you taken this? Okay, so that's why here we do not do nucleophilic aromatic substitution. So what will we do? We have to attack. We have to just addition. How it will see. Here we have a two electrophilic center. This one, electrophilic center, right? This position and this position also. So both are the electrophilic center. Now you have a confusion. The Cn minus where it will attack, right? This Cn minus where it will attack, either this position or either this position. So you have to decide which position is the most electrophilic position. So we know that here is a chlorine is attached, and here is a OMe group is attached, and we know that OMe is a plus M, showing it means it will donate the electron into this ring and make this carbonyl position as a less electrophilic. Okay, and in this case there is a chlorine is attached. Okay, but here it will also show the plus M. It will also donate electron, right? It will also donate electron and decrease this carbonyl reactivity, right? But we also know that the plus M of OMe is a greater than of Cl, right? We also know this. The plus M of OMe is a greater than of a Cl. Why it's so? Because here is a OMe, here is a 2p interaction, but here this is a 3p 2p interaction. Okay, this carbon has 2p and this chlorine has 3p. That's why here is a 3p 2p, and in the case of OMe here we have 2p 2p, and that's why we know that the 2p 2p interaction will be gonna good, and that's why the plus same effect of a OMe is a greater than of a Cl, right? So this thing I hope you all know this, right? That why is the plus same effect of a OMe is a greater than of a Cl. I hope you will all know this, okay? But the condition is here, when this OMe donate their electron in this ring, so it will goes on here. This is a minus I, so this OAT will show as a minus I, because this OAT will show minus I, so it will withdraw this electron, right? Yeah, we know that the OMe is a electron donating group, but when it's donate the electron, when it donate this electron into this ring, and this double bond goes on this carbon, but this carbon we have attached OAT group, and we know that the OAT will show minus I effect, and it will withdraw the electron density of a negative charge, right? It will withdraw the electron density of this carbon, okay, and make the carbonyl not so reactive, will make more reactive, okay. But here in this case there is not such electron withdrawing group, not such electron withdrawing group, like here in this case we have a OAT, but in this case we have not such electron withdrawing group in this molecule. But here in this case we have a OAT, and that OAT is withdrawing the electron density of this ring, and so that this C double bond O position, this C double bond O is a more electrophilic center. More electrophilic center is acting here, more electrophilic center, and that's why the cyanide will attack on this. It looks like a very messy, okay. I have to erase this, okay. So now let's erase, right? So we have something like this. Here is a OAT attached, and here is a OMe, right? And here is a carbonyl aldehyde, and we have a different substrate also. We have here Cl, we have here aldehyde, and we have here Cl minus, right? So the Cl minus will attack on this position, right? And this double bond will gonna shift on as a negative charge on this oxygen. Why I am saying again, why this Cl minus will attack on this position? Because here is also an electron donating group. In this case Cl is also electron donating group, but here in this case this is OAT is also attached, and this OAT is applying the minus I effect, because when the OMe will donate the electron, this double bond will be gonna shift on this carbon, and because from this carbon there is a minus I group is attached, and this group will withdraw the electron, and because it is withdrawing the electron, so the electron density will not reach at this position, and that's why this carbonyl position will become more electrophilic, right? More electrophilic. And that's why what happened next, so that we have OAT, here is the OMe, here is the double bond OH, plus we have another substrate, we have Cl here, we have double bond OH, Cl minus come, will attack on this position, right, and it will gonna shift on this oxygen as a negative charge. So we will found something like this. Here is the O80, here is the OMe, right, and here is the O minus, and here is the H, and here is the C triple bond N. And we know that, and we also know that this hydrogen is a more acidic proton, more acidic proton due to this minus F group, right, and that's why this and that's why this O minus will take proton of this. Okay, so you will get something like this, something OET, here is the OMe, and here is the OH, and here is the H, and wait, H is already obstructed by O minus, so here is cyanide, and here we have a negative charge. So what will happen next? So let me erase this all. So we have something like this, OET, right, OMe, double bond, OH, wait, we have here O minus, OH, because the O minus has already taken the proton. We have here cyanide, and here we have negative charge, and this negative charge is acting as a nucleophile, because in the solution we have another molecule is present. What's the molecule? This is the molecule, and because this position is a this carbonyl is the electrophilic center, and that's why this negative charge will attack on this, and this double bond will gonna shift on the oxygen, and now we get something like this. Very interesting molecule you will get in the final product. Very beautiful molecule you will get, don't worry. Okay, and here you have a H here, C triple bond N, and here you have it will get O minus here, right? Okay, and here you have something like this. Here is the chlorine, right? Okay, fine, and here is the H. Because in this molecule we have also this hydrogen is a more acidic proton, right, because it is attached to more electronegative atom oxygen, so that's why this is a acidic proton. And we have in this molecule here is a O minus, and because this O minus is acting as a base, and so that it will take proton, this O minus will take proton of this hydrogen, and you will get something like this. Here is the OAT, here is the OMe, and here is the O minus, and here we have cyanide, and you have here OH, and wait, and here you will get something like this. This is a chlorine. Okay, so what happened next? So what happened, because we already know that we have taken the NaCN, the CN as a catalyst, and the catalyst has to be regenerate, and that's why the O minus charge will come back, and this CN minus will be regenerated as a catalyst, and then you will get product. Okay, so you get product. Let me erase, okay, because things gonna messy. Let me erase this part, right, and you will get product something like this. Here is a OAT, here is a OMe, and here we have double bond O, and this is the OH, and this is the fluorine. This is our final product of this reaction, right? This is our final product. This is our final product of this reaction. Okay, fine. This is our final product. Okay, product of this reaction. So this question is very, very important, because you will have to apply so much your brain, right? Because you have a different electrophilic centers, so that's why there is a more possibilities of attack. Like you have to choose whether I have to attack on this position or this position. Okay, so this question is very, very important, right? And this is all about benzoin condensation reaction. Okay, and I hope that you will understand very clearly, very precisely. Okay, and if you have understand, then please like, share and subscribe this channel, because on this channel we were gonna only do organic chemistry, pure organic chemistry. Okay, only organic chemistry we will gonna do, right? So just stay with me and be safe. Okay, and तब तक के लिए टाटा, बाय बाय, सी यू सून in the next episode of organic name reaction. Thank you so much.